Okay, guys, here is the video with the last few problems from 3-5. Starting with number 5. Find the first three terms in an arithmetic progression. If the third term, a sub 3, is 14, and the ninth term is -1. So again, there's a couple different ways we can do this. Let me just show you one way. Let's use our formula. First, with knowing that the third term is 14. So I'll plug in 14 for a sub 3. I don't know what the first term is, so that's unknown. And if I plugged in 14 for a sub n, that means you're plugging in 3 for n, and I don't know what the common difference is. If I plug in a sub 9 or -1 for a sub 1, that'll give me a second equation. So I'll plug in -1 for a sub n. Again, the first term's unknown. Since we plugged in -1 for a sub n, that means we're plugging in 9 for n. And again, we don't know the common difference. So gentlemen, look at what we just set up here. You've set up a system. Let me clean up these two equations. The first one, a sub 1 plus 2d is equal to 14. Second equation, a sub 1 plus 8d is equal to -1. So it's a system of two equations with two unknowns. This is a nice system where we can just subtract and eliminate the a sub 1s, and I get -6d is equal to 15. Dividing both sides by -6, I get a common difference of -5/2. Okay? So that's really all we need, right? So we want the first three terms in the sequence. So we know the third term is 14. We just want to know the two terms that precede it. If the common difference is -5/2, if I want the term preceding 14, you would add 2.5. And again, the term preceding 16.5, add 2.5 again, and we get 9. So there's the first three terms. Good. Okay. That formula that we learned is very useful. So let's try this one here. Okay. Find three terms in an arithmetic progression whose sum is 9 and whose product is 24. Find three terms in an arithmetic progression whose sum is 9 and whose product is 24. So your first thought is this, I don't know what these three terms are. We know it's arithmetic. So you could call the first term A, the second term A plus the common difference D, and the third term A plus twice the common difference D. And then you can set up a couple of equations knowing that the sum of these three is 9. So you would add them up to get 9. And the product of these three is 24. So you would multiply those three expressions to get 24. But I think it would be better if we call the three terms something else. Let's call the second term A. And if it's arithmetic, the third term would be A plus D. And the first term would be A minus D. Now you might be asking, why is this better, Mr. Balloon? Well, if the sum of these three terms is 9, when I add those up, don't those D's cancel and I just get 3A is equal to 9 and boom. You get that first term of 3, okay? So now let's plug 3 in for A into these three expressions. First term is now 3 minus D. Second term is 3. Third term is 3 plus D. And let's use the fact that we know that the product of these three terms is 24. Product implying multiplication. This is just algebra here, okay? So if I divide both sides by 3 and multiply out those conjugate binomials, I get 9 minus D squared is equal to 8. Or D squared is equal to 1. So D is equal to either plus or minus 1. So really, I've got two answers, okay? If A is 3 and D is 1, then the three terms are going to be 2, 3, 4. But if A is 3 and D is -1, then my three terms will be 4, 3, 2. We do need both of these answers, okay? Need to cover our bases. Okay, last one. This is kind of important. Find the value of x if these three expressions in this order, form an arithmetic progression. And check that you really have an arithmetic progression. Now, remember what an arithmetic progression is. It is a sequence or a progression in which you get the next term by adding the same number. And that term that we add, or that number that we add, I should say, is called the common difference. And it's called the common difference. Why? Well, think about it. Here is an arithmetic progression. I think we can all see that the common difference is 6. And it's called a common difference because if you take the difference between two terms, 19 minus 13, or 25 minus 19, or 7 minus 1, that difference is common. It's 6, right? So let's use that fact to solve for x. If this is an arithmetic progression, then the difference between successive terms, so if I take the second term and subtract the first term, that difference should be the same if I were to take the third term and subtract the second term. That's the idea of the common difference. Look, there now is an equation in which we can solve for x. So let's do it. Let's combine like terms on the left. Let's distribute the minus sign and collect like terms on the right. That becomes 4x minus 5. Let me add x to both sides. Let me add 5 to both sides. And I get I get a value of x of 8/5. So guys, if we were to plug in 8/5, 8/5, there's an 8. If I plugged in 8/5 for each one of these x's, those terms would be, the first one would be 16/5. Second term would be 8/5 plus 3, or 8/5 plus 15/5, which is 23/5. And the third term would be 5 times 8/5 minus 2, which is 6. Is this an arithmetic progression? You can check. See if there is a number that we're adding each time to get from one term to the next term. Looks like from 16/5 to 23/5, we're adding 7/5. If I add 7/5 to 23/5, I get 30/5, which is 6. Good. So the answer to the question is 8/5. Okay, guys, you should be good to do 3-2 and 3 for our next class meeting. I will see you soon.